Good evening everyone, good evening. I welcome you all again to the NEET Elite. Hope you guys are doing great, having the good time. Well people, let me know in the chat box if I'm audible and visible to everyone. Yes, my throat is slightly in a bad condition, so I cannot shout in the tonight's session, okay, like I used to do. Good evening everyone, good evening. Welcome to the session guys. Welcome back. Well, Yashwant has come up with the quote, but I couldn't read the quote. Welcome guys, I'm doing great. I'm doing wonderful. I'm doing better than before, Priya. I'm doing better than before. मैं बिल्कुल ठीक हूँ सानिया, आप बताओ. All right guys, fine. Okay, so as you all must be knowing, today is our 5th session of the general organic chemistry, right? And people, in the tonight's session, what we are going to talk about is, we are going to talk about the cross and extended conjugation. We'll be talking about the stability of the resonating structures at the same time, okay? First, we'll get to know what this cross and extended conjugation is all about, okay? Then I'll show you how to compare the stabilities of different molecules through the extended and cross conjugation method, yes? Okay. Alright, so before starting the session, let me introduce myself. As you all must be knowing now, my name is Wassim Sir and I'm your chemistry master teacher right here. Okay. Alright guys, for the ones who have no idea about the NEET 2021 crash course which we have started on the actual Vedantu platform, well people, what all benefits you guys are going to get if you'll enroll yourself in this NEET 2021 crash course. The first thing, we are going to cover your whole syllabus before the NEET 2021 examination through the actual Vedantu platform, right? And you're going to get trained by the teachers of your choice, yes? And people, no need to worry about the mock tests, no need to worry about the assignments, no need to worry about the test series. Everything is included right here in this NEET 2021 crash course, okay? And at the same time guys, apart from the syllabus completion sessions, there will be some other sessions regarding the time management, regarding the tips and tricks by means of which you can solve the questions in lesser time. And at the same time, it's going to be a two-way learning interactive platform wherein you can ask your doubts anytime to your master teachers, okay? All right. How to get enrolled in this NEET 2021 crash course? Well, you just have to click on the Vedantu app. After clicking on the Vedantu app, you just need to click on the NEET crash course. And after clicking on the NEET crash course, what you guys are going to do is, you just need to apply the coupon code as WSCC if you want me to train you personally in your chemistry for the upcoming NEET 2021. Yes, and at the same time, on applying this coupon code, you guys are going to get 20% off at the same time, and you guys are just getting this crash course for 8K after the 20% off. Yes? Okay. Well, the next batch is starting on the 8th of March, okay? So people, I want you guys to get enrolled in this one so that we can kill it together, yes? So you have got one more way by means of which you can get enrolled in this crash course. That is, there is a link in the description box of the video. I want you guys to click on that link, use the coupon code WSCC and get enrolled in this crash course over here, okay? For the ones who have not liked the video yet, please do like the video, share and subscribe the channel at the same time so that everyone gets benefited out of these sessions, right? Yes? Well, Sohail, I'm an engineer basically, okay? All right. Well, as I told you in the beginning itself, what we are going to talk about in the tonight's session is, we are going to talk about the cross and extended conjugation. We'll be talking about the stability of the resonating structures at the same time, okay? Yes. So let's get started. Without wasting a lot of time, let's get started with something called as cross conjugation, okay? What is this cross conjugation all about? Let me first of all tell you the definition of it. Then I'll make you understand what this cross conjugation is all about, okay? See guys, its definition might look strange to you, but in some time I'm going to explain that to you, okay? And as per the cross conjugation is concerned, it is basically whenever in a molecule you have got a particular pi electron pair simultaneously in conjugation with two other pi electron pairs which are not in conjugation with each other. That sort of conjugation is what we call as cross conjugation. Did anyone get the idea of what I said? Did anyone get the idea of what I said? I'm going to repeat this again, okay? Whenever in a molecule, a particular pi electron pair is simultaneously in conjugation with two two other pi electron pairs which are not in conjugation with each other, we call that conjugation as the cross conjugation. Let me know in the chat box if you got the definition of it. No? Yeah? Yes, Karthik, it looks weird, yeah? It looks weird. Yes, I'll make you understand this in a while, okay? See guys, I've written something like this. Whenever a particular electron pair competes for delocalization with other two pi electron pairs which are not conjugated. Whenever a particular electron pair competes for delocalization with the other two electron pairs, with the other two pi electron pairs which are not conjugated, it's called as cross conjugation. Now what is that? I'll show that in a while, okay? But before talking about that, let me give you the definition of the extended conjugation as well, right? If the pi electron pair gets delocalized in the same direction, if the pi electrons gets delocalized in the same direction, that's what we call as extended conjugation. What is meant by all this? Have a look. See guys, I've taken two molecules right here. Understand properly what I'll say. See guys, if I talk about this pi electron pair right here, this is the pi electron pair, for example, right here, okay? This is the pi electron pair. Can I say this pi electron pair is simultaneously in conjugation with this pi electron pair as well as this pi electron pair? Yes. A particular pi electron pair is in conjugation with this pi electron pair as well as this electron pair? Yes. But people, are these two pi electron pairs in conjugation with each other? No, they are not in conjugation with each other. Whenever you get this sort of a situation in which a particular pi electron pair is simultaneously in conjugation with two other pi electron pairs, but those two pi electron pairs are not into conjugation with each other, we call this sort of a conjugation as cross conjugation right here, okay? Yes. And people, when the pi electron pair gets delocalized in the same direction, that's something called as extended conjugation. Right here, the pi electrons, these pi electrons, this is pi, sigma, pi, sigma, pi. These pi electrons can get either delocalized in this direction or they'll get delocalized in this direction. Whenever you see this sort of a conjugation, this is what we call as extended conjugation, or you can call it as linear conjugation normally, okay? Yes. Remember guys, remember extent of resonance in cross conjugation. I'm writing it over here for you. Extent of conjugation in cross one. Yeah, I can write something like this. Extent of resonance in cross conjugation is always less than that of the extent of resonance in extended conjugation. Remember this. Okay? Extent of resonance in cross conjugation is always slightly lesser than the extent of conjugation in the extended conjugation. Okay? Why is that? Why is that, if I'll ask you? See, this electron pair, this pi electron pair, it is simultaneously in conjugation with this one as well as this one. Yes. But at a particular instant, it can show delocalization with either this one or with this one. Yes. So out of 3 electron pairs, at a particular instant, only 2 pi electron pairs can show delocalization. But over here, all these electron pairs simultaneously can show delocalization. Yes. So I can say extent of resonance in cross conjugation is always less than the extent of conjugation in the extended one, right? And people, remember, stability is directly proportional to extent of resonance. I hope you know that. Yes. Stability of the molecule is directly proportional to extent of resonance. More the resonance happening in the molecule, more is going to be its stability. Less the resonance happening in the molecule, less is going to be its stability. Let me know in the chat box if everything is clear till here so that I can show you a few more interesting things right here. Let me know in the chat box. Yes? Selvan, I'm going to teach the chemical bonding soon, bro. Just wait for it. Absolutely, guys. So what you got to know till now, in case of extended conjugation, extent of resonance is more than that of cross. So what I can say right here, I can say stability of this one will be definitely greater than the stability of this one. Yes. And when I should use this concept, to compare the stabilities of two molecules, remember, when the pi bonds in two molecules are same, then only I'll be using this concept to compare the stability of the two molecules, okay? Yes, got it? Now, Now guys, have a look. Understand what I'll say. This is something which I told you, extent of resonance in cross conjugation is less than the extent of resonance in extended conjugation, number one. And at the same time, few minutes back, I told you extent of resonance is directly proportional to stability. More the extent of resonance, more the stability. Less the extent of resonance, less the stability. Yes? This is something which I told you right now. Yes? Now let's try to do some questions based on the concepts which I gave you right now. Okay? Now people, the first question which is on your screen. I need to compare the stabilities among these two. See, the first question is, I have got this molecule, I have got this molecule. I need to check which one is more stable. Can you let me know in the chat box, what do you think, which is going to be the more stable among the two? Yeah? Can you let me know in the chat box? Can you let me know in the chat box? Well, I can see a lot of people are saying one is more stable than two. Can you let me know why? See guys, if you check the second molecule right here, we have got lone pair sigma pi, lone pair sigma pi. So right here, can I say I have got the case of I have got the case of cross conjugation right here. Yes, this particular lone pair is in conjugation with this one as well as this one. So isn't this the case of cross conjugation? And I told you extent of resonance in cross conjugation is less than that of extent of resonance in extended conjugation. Yes. So right here, this is the case of what? This is the case of cross conjugation. So in case of cross conjugation, extent of resonance is less the extent of resonance, less is going to be the stability. Yes. So I got to know this one is less stable than this one, or I can say the first one is going to be more stable than the second one. Yes, correct. Absolutely guys, you all are perfectly correct. Yes. Okay. What about the second one? And people, I told you a few minutes back when to use this concept when the number of pi bonds are same. So right here I had 2 pi bonds, that's why I use the concept of this cross conjugation right here, okay, in order to compare the stability, okay. If the pi bonds were different, I was not supposed to use this concept right here, okay. Now the case is the second one. Which one is more stable among the two? What do you think? Are the pi bonds same in both the ones? Yes, the pi bonds are same in both the ones. Over here we have got 3 pi bonds. Over here we have got 3 pi bonds, right? I need to check which one is more stable. What do you think? Let me know in the chat box. Well, I can see a lot of people saying second is more stable. Why is that? Absolutely guys, all of you are perfectly correct. Why is that? See. Right here, this pi bond right here is simultaneously in conjugation with this one as well as this one. So can I say over here I'll be using the concept of cross conjugation? Yes. So right here, this is the case of cross conjugation. Again, over here in this molecule, it is the case of cross conjugation, and extent of resonance and cross conjugation is less, right? So extent of resonance is directly proportional to stability at the same time. So if extent of resonance in this one is less, that means it's going to be less stable, right? So stability of the second one is going to be more than that of the first one. Yeah, correct. Absolutely, guys. Perfect. Yes. Okay. What about the next one, guys? Let me know the stability order in the third one. What do you think? I'm waiting for your answers. Well, again, I can see people are saying 2 is greater than 1. Is that? Absolutely, guys. Right here, if you can see, this is the negative charge, this is sigma, this is pi. So right here, I have got the conjugation. At the same time, this negative charge is in conjugation with this pi electron at the same time. Yes. So this negative charge is simultaneously in conjugation with this one as well as this one. So should I be using the case of cross conjugation in this one? Yes, I should be doing that, right? And we know extent of resonance in cross conjugation is less. So I can directly say stability of this one is going to be less than that of second one. Yeah. And people, the important point is that when you'll be using this concept, when the number of pi bonds in both the molecules are going to be same, okay, then only you'll be using this concept. Yes, absolutely, guys, absolutely, right? Okay, let's move on to few more. Let me see if you can let me know the answer of this question right here or not. In which of the following negative charge is more stable? Right? Let me know in the chat box. I'm waiting for your answers. In which of the following negative charge is more stable? People, if I ask you what happens due to the resonance, People, due to the resonance, dispersion of charge takes place. Remember, more the dispersion of charge due to resonance, more will be the stability of the charge, right? more the dispersion of the charge, less is going to be the volume charge density, less is going to be the charge density. If less is the charge density, more is the stability. Yes, or simply I can say like this, more the dispersion of the charge, more is going to be the stability, correct? This is one important point which I'll be using in the questions, right? Now people, have a look on this question right here, okay? Have a look on this question right here. I need to compare the stability of negative charge among the two. So a lot of people are saying one is more stable than two. The negative charge over here is more stable than the negative charge over here. Is that what you're saying? Let's get to know. See, right here we have got a negative charge. Just a second, guys. Okay, right here we have got a negative charge. This is sigma, this is pi. So right here it can show the conjugation. Yes, it can show the conjugation, correct? And the conjugation is going to be like this. It's going to be like this. Yes. But right here at the same time in the second molecule, what is going to happen? What is going to happen? So first of all, negative charge is being dispersed, right? Negative charge in one canonical form is going to be on this one, and in another canonical form, negative charge is going to be on this oxygen. Yes, correct? But right here, guys, if I check this molecule right here, can I say this pi electron pair is in conjugation with this negative charge as well as this lone pair, right? Can I say again this is the case of cross conjugation? So extent of resonance right here will be less. Dispersion of charge right here will be less, and wherever dispersion of charge is going to be less, stability is going to be less, right? So which one is going to be more stable among the two? Definitely first is going to be more stable among the two. Yeah, I can say that, correct? Yes. Yes. Right? First is going to be more stable than the second, correct? Because in the second one, it is the case of cross conjugation. Extent of resonance will be less. If extent of resonance is less, definitely dispersion of negative charge will be less. If dispersion of negative charge is less, stability of negative charge over here will be less, right? Correct? Yes. Saran, actually, throat issues, bro. That's why, yeah. Throat issues a bit. That's why my tone is a little low today. Okay, now guys, let me give you one more. There is something called as negative charge holding capacity. People, if you remember the first session of organic chemistry, the basics of the organic chemistry, I told you in detail, if you remember, negative charge holding capacity is directly proportional to the electronegativity of the atom. More the electronegativity of the atom, more is its tendency to hold the negative charge density, right? So I can simply say negative charge holding capacity is directly proportional to electronegativity of the atom, right? Yes, and people, if you remember, I have told you one more thing. Negative charge is more stable on more electronegative element. Positive charge is more stable on less electronegative element. This is something which I have told you in the beginning only. Yes. Okay. Now people, one important statement I have written right here. Negative charge holding capacity of one oxygen atom is greater than negative charge holding capacity of 10 carbon atoms. This is very, very important, okay? Negative charge holding capacity of a single oxygen atom is greater than the negative charge holding capacity of 10 carbon atoms, guys. 10 carbon atoms. Where I'll be using this statement. Understand what I'll say. Okay, before showing the question, I told you just now. Negative charge on a more electronegative element, right? Negative charge is more stable on more electronegative element. Positive charge is more stable on less electronegative element. And right now, this is one more statement. Negative charge holding capacity of one oxygen atom is greater than the negative charge holding capacity of 10 carbon atoms, right? Now people, how I'll be using this sort of statement right here. See guys, this is first of all the case in which I was supposed to check the stability of the negative charge, right? In which of the species right here negative charge is going to be more stable? Well people, understand one important thing. Right here in this OH, the negative charge is on oxygen, yes, right? Negative charge right here is on this carbon. But this negative charge is in conjugation with this one as well, right? Can I say due to the conjugation, this negative charge can come here? This negative charge will form a pi bond right here, and this negative charge will be here. At the same time, in one more canonical form, it's going to be like this. It will break towards this, so negative charge will be on this carbon, right? And in one more canonical form, it's going to be like this. This will break towards this, so negative charge will be here, correct? Can I say negative charge is dispersed on 4 carbon atoms? 1, 2, 3, and 4. Yes. And negative charge right here is on oxygen atom. But we know negative charge holding capacity of one oxygen atom is more than the negative charge holding capacity of 10 carbon atoms, right? And over here, the negative charge is being dispersed only on 4 carbon atoms, correct? Yes. So in which of the following negative charge is going to be more stable? What do you think? What do you think? What do you think? First or second? Definitely, guys, first. Yes, definitely first. Negative charge will be more stable in the first one. Because right here, negative charge is on oxygen. No doubt, negative charge is dispersed on 4 carbon atoms right here. But negative charge holding capacity of 1 oxygen atom is greater than the negative charge holding capacity of 10 carbon atoms, right? Yes. Exactly, guys, exactly. All right, I'm moving ahead. I'm going to use this concept a bit more in detail. Understand what I'll say, okay? Say, guys, if the charge holding capacity is nearly the same, then the stability is directly proportional to the number of resonating structures. The molecules which I've shown you before, in those molecules, in the first one, the negative charge was on oxygen. In the second one, the negative charge was on carbon, right? So the negative charge holding capacity of atoms was different. The negative charge holding capacity of atoms was different because in the first one, the negative charge was on oxygen. In the second one, the negative charge was on carbon atoms, right? But right now, what I'm saying is, if the charge holding capacity is nearly the same, then the stability is directly proportional to the number of resonating structures. What does that mean? What does that mean? Understand. See, guys, these are few cases which I've shown right here. Okay? These are few cases which I've shown right here. I need to compare the stability of these two. I need to compare the stability of negative charge in these two and then in these two. What do you think should be the answer? See, guys, let me call this as 1. Let me call this as 2. Let me know the stability of negative charge in these molecules right here. What do you think? What do you think? Well, I can see 2 greater than 1. Yeah, is that? Absolutely, guys, you all are perfect. Yes, correct. Why is that? Have a look. First of all, if I'll make one more resonating structure of this molecule, this negative charge will come here and this negative charge, this pi bond will break towards this. So negative charge can be either on this carbon or on this carbon. Yes, right? But people, at the same time, due to resonance, this negative charge can form, you can get the double bond right here. This bond will be broken down towards this. So negative charge right here, then this will come here, this will come here. So negative charge right here, then this will come here and this will go here, then negative charge on this one. So can I say negative charge right here is dispersed on 4 carbon atoms? And right here, negative charge is dispersed only on 2 carbon atoms. More the dispersion of the charge, more is going to be the stability. So where is the dispersion of charge more? Dispersion of charge is more in the second one. So second one is going to be more stable than that of first one. Yes, correct? I can say something like this, correct? Or you can simply say, right here we have got only 2 resonating structures, right here we have got 5 resonating structures. Wherever the resonating structures are more, there only dispersion of charge is going to be more. And wherever dispersion of charge is going to be more, there only stability is going to be more. Yes, absolutely, correct? Yes, I can say that. Absolutely, guys. Second one is going to be more stable than the first one, correct? Now, in these two, what do you think? What do you think? What do you think, guys? Is the negative charge holding capacity of the atom same right here in these two? Understand what I'll say. First of all, if you make the resonating structure of this one, this negative charge will come here. This pi bond will be broken down over here. So negative charge will come on oxygen atom, right? In one more resonating structure of this molecule, what is going to happen? Negative charge is coming on oxygen, correct? So negative charge is either going to be on this carbon or on this oxygen right here, correct? And people, if you do the dispersion of charge right here, what is going to happen? Right here, you'll get the pi bond. Then pi bond gets broken down towards this one. So negative charge on this, or negative charge on this, or negative charge on this, right? No doubt, right here, negative charge is dispersing on 4 carbon atoms, right? Negative charge is dispersing on 4 carbon atoms right here. But at the same time, over here, negative charge is coming on the oxygen atom. And oxygen atom has got more negative charge, right? It has got more negative charge absorbing capacity, I must say. Yes, correct? So which one is going to be more stable? Which one is going to be more stable? First or second? Absolutely, guys, first. Absolutely first. Right? Because this oxygen has got more negative charge carrying capacity. Yes, I can say that. Absolutely, because of oxygen atom, okay? Let me give you a few more examples. Let me see what you are going to. Let me know the answers of that. Okay, see, guys. If the charge holding capacity is nearly the same, then the stability is directly proportional to the number of resonating structures. This is something which I told you. Now, people, let's try to compare the stability of the charges in these two, then in these two, okay? Let me call this 1, let me call this 2. Similarly, let me call this as 1, let me call this as 2. Let's try to do the first question. Yes? Can you let me know the answer of first question? What do you think? What do you think? Which is going to be more stable? And which of the following negative charge is going to be more stable? Are you actually saying 2 in 2 it's going to be more stable? Yeah? Is that? Can you let me know why? Can you let me know why? I'm waiting for your answers. Wonderful, guys. Great. Absolutely, absolutely. In 2, it's going to be more stable than that of first, right? Why is that? Have a look. Have a look. Understand. See, guys, if I try to draw one more canonical structure of this one, what is going to happen? What is going to happen? This negative charge will come here, and this pi bond will be broken down towards this oxygen. So either the negative charge is going to be on this carbon, or the negative charge is going to be on this oxygen. Yes. Right here also we have got oxygen carrying negative charge. Right here also in this molecule we have got oxygen carrying negative charge. And you can make the resonating structures at the same time. So due to the other resonating structures, in one resonating structure the negative charge will be on this one, in one more negative charge on this one, in one more negative charge on this one. Correct? So people, right here we have got oxygen carrying negative charge. Right here we have got oxygen carrying negative charge. Correct? So I'm not going to compare in terms of oxygen. I'm going to compare in terms of what? Resonating structures. More the resonating structures, more the dispersion of charge. More the dispersion of charge, more is going to be the stability. So can I say simply like this? Negative charge is going to be more stable than the in the second one than that of first one. Yeah. Correct? Exactly, guys. Exactly. Perfect. Perfect. Yes. Okay, what about these two, guys? What about these two? What about these two? What do you think? Right here, this negative charge can be either on this oxygen or it can be either on this oxygen due to the resonating structures. Yes, correct. So we have got 2 oxygens with negative charge carrying capacity. Right here we have got only 1 oxygen with negative charge carrying capacity. More the oxygen atoms carrying negative charge, more is going to be the stability, right? Correct? One is going to be more stable than that of second. Correct? Yes? Absolutely. Perfect. Perfect, guys. Perfect. Let's try to do a few more questions. Let me see if we have more questions or not. Okay. Arrange the following in the stability order. Yes, we need to compare this stability order. Yes. Let me know the stability order of these. People, you should be able to draw, you should be able to tell me the correct order now. Okay? You should be able to tell me. What do you think? Which one is going to be more stable? Well, you guys are actually doing wonderful. You guys are actually doing great. That means you are getting the concept. That's great. This is something which I wanted. Exactly, guys. See, right here, the negative charge is either going to be on this one or on this one. So we have got 2 oxygens with negative charge carrying capacity right here. Yes, right here we have got 1 oxygen with negative charge carrying capacity. Right here, no oxygen with negative charge carrying capacity. So I'll be giving preference to the one where there are more oxygen atoms with negative charge carrying capacity, right? So I can say first one is going to be maximum stable. In the first one, the negative charge is going to be maximum stable, followed by the third one, then the second one. So this is going to be the order. Yeah, A, B, C. A, then C, then B. Correct? Let me know if it's clear to every single guy right here. Let me know in the chat box. Let me know in the chat box. Let me know in the chat box so that I can give you few more questions right here. Yes, all of you are perfectly correct, guys. All of you are perfectly correct. Yes, all of you are perfectly correct. Okay, now guys, see. What do you think in these? What do you think in these? Arrange the following in stability order. Arrange the following in stability order. What do you think? Which one is going to be more stable? Which one is going to be more stable? I mean, wherein positive charge is going to be more stable. Wherever dispersion of charge is going to be more, there only stability is going to be more. Yeah, we know that. Yeah. Absolutely. Perfect. So people, what is going to happen? What is going to happen? We have got pi, sigma, positive charge, correct? So conjugation. So resonance is going to happen, right? Due to resonance, positive charge is either going to be here, positive charge is either going to be here, or positive charge will be here, or positive charge will be here, or positive charge will be here. Correct? Correct, due to the canonical forms. And people at the same time, due to the resonance, either the positive charge will be on this carbon or the positive charge will be on this carbon right here. Okay, where is the dispersion of positive charge more? Dispersion of positive charge is more in the second one. Wherever dispersion of positive charge is more, then only stability of the charge is going to be more. So second is going to be definitely more stable than that of first. Yes? Right? Correct? Absolutely, guys. Perfect, perfect, perfect. All right. Now. What is going to be the order over here? What is going to be the order over here? What is going to be the order over here? Let me see what is going to be your order. Let me see what is going to be your order right here. Let me know fast in the chat box. Just think over it. Well, Insha, these are not only 4, these are 6. You have to consider this E and F with it. Okay, these are not A, B, C, D only. This is A, B, C, D, E, F. Okay, these are 6. Let me know fast in the chat box. People, you have to consider all the 6, then only let me know the stability order. Abhi, you can do one thing. You can just take the video a little back, drag the video a little back. It will be automatically a replay for you, okay? Which one is going to be maximum stable among the following? Well guys, have a look. Right here, we do not have any oxygen. Right here, we have got one oxygen which can get negative charge. Right here, we have got 2 oxygens which can get negative charge. Right here, 1 oxygen which can get negative charge. So first of all, I'll be giving preference to the oxygen atoms which can get negative charge. Correct? Yes. So I'll be giving preference to this one. This is going to be my priority number 1. Correct? It's going to be the maximum stable among all. After that, this is going to have negative, this has got the oxygen atom, this has got the oxygen atom, but right here, we'll be having more resonating structures at the same time. So I'll be giving second priority to this one. Similarly, third priority to this one. Now, which one are left? This one, and this one. Right here, this negative charge can be on nitrogen. Right here, this negative charge can be on nitrogen due to resonance. Yes. And negative charge on more electronegative element is stable. Yes. So I'll be giving fourth priority to this one. This was 1, this was second, this one third, this was 1 fourth. Okay. Now, what about these two? It's simple. Over here, more resonating structures, more the dispersion of charge, more is the stability. So this is going to be the 5th one. This is going to be the 6th one. So what is going to be my order, right? The stability order is going to be first, I'll be writing D. Then at the second place, it's going to be E, right? At the third place, which one is there? At the third place, it's going to be B. Yes, at the fourth place, it's going to be what? It's going to be C. At the fifth place, it's going to be F. And at the sixth place, it's going to be A. How many of you got this as the stability order? Let me know in the chat box. Let me know in the chat box how many of you got +4 marks in this. Yeah. Yes. Great, guys. Wonderful. Yeah. Are you actually finding this interesting? This is actually interesting, guys. This is damn interesting, yeah? Because it's very easy for you, correct? All right, great. Fine. Let's move on. Let me know in these two. It's a very simple one. This is something which I've shown you in the first session itself. What do you think? Which one is going to be more stable? Which one is going to be more stable? Which one is going to be more stable? People, it's a simple question. Very, very, very simple question. See, guys, this is sp hybridized, right? This is sp2 hybridized, right? Because this negative charge is in conjugation, so it will take part in resonance. I won't be counting this negative charge for the in order to calculate the hybridization of this one. Yes, this is sp, this is sp2. Over here, I'll say more is the s character, more the electronegativity, right? Negative charge on electronegative element is more stable. So first one is more stable than the second one. Yeah, I can say that. Correct? Exactly, guys. Exactly. Perfect. All right. Let's move on to this one, okay? This is something which I'm trying to give you the homework, okay? Just let me know the answer of this one in the comment box afterwards. Not here, okay? Let me know the answer of this one in the comment box afterwards. And I'm sure you can easily kill this. Yeah? Cool? I'm moving ahead. Okay, arrange the following in the stability order. What do you think? Arrange the following in the stability order. What do you think? Arrange the following in the stability order. A or B? A or B? A or B? I'm waiting for your answers, guys. Let me know. Priya, I do not know. You have to let me know the answer in the comment box afterwards, okay? A or B? Which one is going to be more stable? See guys, understand. It's a very, very simple thing. It's a very, very simple thing. Well, I can see a lot of correct options are coming up. That means actually you guys are getting it, okay? Now guys, see, over here, negative charge is on carbon. Where, just a second guys, where has it gone? Just a second, yeah, this is the question. Okay, so right here, negative charge is on carbon. Right here, negative charge is on oxygen, yes. Can I say this negative charge is in conjugation with this pi bond, this pi electron pair? This negative charge is in conjugation with this pi electron pair as well. So I can say due to conjugation, this oxygen is also going to get negative charge and this oxygen can also get negative charge. Correct? So we have got two oxygens with negative charge carrying capacity right here. We have got only one oxygen with the negative charge carrying capacity right here. More the oxygens with negative charge carrying capacity, I'll say more is going to be the stability. So which one is going to be more stable? Definitely A is going to be more stable than B. Yeah. How many of you got it right? Let me know in the chat box. How many of you got it right? Let me know in the chat box. Yeah. Yes, Hadi will be doing bonding at the same time. We'll be doing bonding as well, okay? Just wait for a few days. After that, we'll be starting bonding. But we'll be doing bonding and this organic parallelly, okay? One day bonding, one day organic, like that. We can switch. Perfect, guys. Perfect. Let's move on to something interesting. Extent of resonance. Okay? Now, people, the first thing which I have written right here. Extent of resonance is directly proportional to strength of overlap. Extent of resonance. What is resonance basically? Resonance is the overlap of orbitals, right? Which we have seen in the first session itself, correct? It's actually the overlap of orbitals, right? Yes. Extent of resonance is directly proportional to strength of overlap, right? Right? Okay, what does that mean? See guys, first thing which you must know right here, extent of overlap in 2p is always greater than, in 2p 3p is always greater than 2p 4p. This is something which you would have studied in chemical bonding also, right? Extent of overlap in 2p is always going to be maximum, followed by 2p 3p, followed by 2p 4p. Okay, this is something which I want you guys to remember. Wherever you see a resonance happening in which 2p orbitals are overlapping, in which 2p orbitals are parallelly overlapping, remember there only extent of overlap will be more, and wherever extent of overlap will be more, there only extent of resonance will be more, and wherever extent of resonance is more, there only stability is going to be more. Yeah, this is something which I want you guys to remember. Okay, Ayush, just drag the video a little back, it will be a replay. Okay, see guys, where I'll be using this concept. Okay, see where I'll be using this concept. Let me know in these two. Where is the extent of overlap more? What do you think? Where in these two is the extent of overlap more? I'm waiting for your answers. Yes, let me know. In A, definitely guys, definitely. Right here, it's going to be a 2p overlap, right? Right here, it's going to be a 2p overlap, and extent of overlap in 2p is going to be more than that of extent of overlap in 2p 3p. Yes, 2p 3p overlap. Extent of overlap in 2p is greater than the extent of overlap in 2p 3p. Wherever extent of overlap is more, there only extent of resonance is more. Wherever extent of resonance is more, there only stability is more. So we can talk in terms of extent of overlap, we can talk in terms of extent of resonance, we can talk in terms of stability as well. Yeah, we can tell anything right here. Yes, perfectly correct. perfectly correct. So A is going to show more overlap because it's going to be a 2p overlap. B, it's going to be over here 2p 3p overlap, right? Extent of overlap will be more in that of first. Yes, correct. And at the same time, extent of resonance will be more in that of first, and stability will be more in case of first. Yeah, right? Okay, now guys, have a look. Order of extent of resonance. Order of extent of resonance of what? See, this is something which I have shown you in the first session, if you remember, right? See, I told you in the first session itself, a high energy electron pair shows the delocalization, if you remember. Yeah, high energy electron pair shows the delocalization, if you remember, right? A high energy electron pair is showing a high energy electron pair will be always showing the delocalization. Now remember, negative charge with a lone pair has got the maximum energy, followed by the lone pair, followed by the double bonded one, followed by the triple bonded pi electron. Yes, right? Or you can simply remember it like this. You can simply remember it like this. Negative charge with a lone pair is going to show maximum resonance, followed by the lone pair, followed by the pi electron of double bond, followed by the pi electron of triple bond. Okay? Yes. Ronit, I'm not sleepy, bro. It's just my throat is aching a bit. That's why my tone is a little low. Okay? Fine. Remember, guys, negative charge with the lone pair will show maximum resonance, followed by the lone pair, followed by the pi electrons of the double bond, followed by the pi electrons of the triple bond. Okay? Now guys, where I'm going to use this concept. There is something missing right here. This is negative charge with a lone pair. Okay? Now you gotta tell me the order of extent of resonance. Order of extent of resonance. Where will be the extent of resonance more? What do you think? First or second? Yeah? Absolutely, guys. Right here we have got the conjugation. This is negative charge with the lone pair, sigma pi. Okay? And this is lone pair, sigma pi. Okay? And I told you extent of resonance is more in case of negative charge with the lone pair, followed by the negative, followed by the lone pair, followed by the pi electrons of double bond, followed by the pi electron of triple bond, right? So extent of overlap is definitely going to be greater in case of first one than that of second one, right? Because we have got negative charge with the lone pair right now involved in the conjugation, right? And wherever you see the negative charge with the lone pair involved in the conjugation, there only will be the extent of resonance more, yeah? Right? Okay, now few more examples. Order of extent of resonance. What do you think? What do you think right now? What do you think? Where will the extent of resonance more? First or second? First or second? Oh, it's already mentioned. I forgot. It's already mentioned, guys, right? In first, it's more. Yeah, it's given. It's given. Do you know the reason? Yeah, few minutes back only I told you, right? Correct? I forgot it's already given. How can they give this one? Anyways, oh my God, what happened? I think this was all for today, guys. Okay? All right. This is all for today, okay? I hope you guys got everything. Well, I didn't notice that, by the way. That it was given from that side only. Yeah? Yes, it was a very short session today, and I think you got the concepts which I told you, correct? People, do you have any sort of doubts in that? Do you have any sort of doubts in whatever I've taught you in the tonight's session? Any sort of doubt? You can let me know right now. हाँ जी, आंसर केमिकल बॉन्डिंग भी पढ़ाऊंगा मैं, सारा पढ़ाऊंगा. Wait. Exactly. This is the first time when our class is getting ended fastly, yeah? Well, Jabin, you can go to the playlist. In that playlist, I have done I guess, 11 lectures I have done for thermodynamics, right? That's all done there. You can check it out. Okay, so for the ones who have no idea about the NEET 2021 crash course, which we have started on the actual Vedantu platform, well, people, if you want to get trained by the teacher of your choice for the upcoming NEET 2021 on the actual Vedantu platform, what you guys are going to do? Before talking about that, let me show you what all benefits you'll be getting right here if you'll enroll yourself in this NEET 2021 crash course. Well, people, first thing, you are going to get trained by the teacher of your choice, by the teachers of your choice, I must say, of your physics, chemistry, as well as biology. Apart from that, entire course will be completed before the NEET 2021 examination, right? Well, people, at the same time, no need to worry about the test series, no need to worry about the mock tests. Everything is included right here in this NEET 2021 crash course. Yes, and definitely it's going to be a two-way learning interactive platform wherein you can ask your doubts anytime to your master teachers, as I always say, right? And it's not only going to be about the course completion, there will be some extra sessions regarding the time management, how to solve the questions in lesser time. Everything will be done and dusted right here by the teachers of your choice. Okay. Well, people, how to get enrolled in this one? You just need to click on the Vedantu app. After clicking on the Vedantu app, just click on the NEET crash course, and after clicking on the NEET crash course, what you guys are going to do is you guys are going to use the coupon code as WSCC if you want me to personally train you for the upcoming NEET 2021. Yes, okay. And after using this coupon code, what you'll be getting 20% off at the same time, right? Yes, and there is a news for you that the next batch for the NEET 2021 crash course is starting on 8th March. So do get enrolled in this one. So kill it, show the bullseye. Let's show the bullseye together. Yes, which I always say. Okay. So there is one more way by means of which you can enroll in this. That there is a link given in the description box. Click on that link. Use the code as WSCC and get enrolled. Well, for the ones whose preparation is up to the mark, who just needs the questions to be solved, right? There's a special plan for you, that is the NEET 2021 test series. Well, if you guys are not interested in taking the crash course, you can take the test series if you want, okay? In this test series, what you guys are going to get, there will be 10 full tests, weekly 2 tests will happen along with the discussion. And the starting date of this NEET test series is 8th of March, okay? One series was started earlier and one more series is starting on 8th of March. So do get enrolled in this one if you really want to get benefited by some 20-30 marks ahead, okay? At the same time, how to get this NEET 2021 crash course, there is again one more link in the description box of the video. Click on that link, use the code WSCC. On using the code, you'll be getting the 20% again, okay? Right? And there is one more link in the description box, which is for Telegram. Do click on this link as well. Get added to the Telegram link. Stay updated about the classes, okay? And for the ones who have not liked the video yet, please do like the video, share and subscribe the channel at the same time so that everyone gets benefited out of these sessions. Well, tomorrow we are going to have the session, okay? Tomorrow we'll be having the session, one more. This is going to be GOC part 6, yeah? Tomorrow at 11 p.m, right? So till then, you guys take care. Bye-bye. God bless you all. Love you all. Take care. See you soon. Bye, guys. Take care. Bye.